Till last lecture, we have studied some fundamentals of hyperbola. In first lecture, we have understood the basics, setup and standard equation, shifted forms and how to derive the characteristics, and also we have solved some questions based on those ideas. So, today we will continue from there. We will spend some time on asymptotes. We will study asymptotes in depth. We will learn how to derive equation using asymptotes, and then we will try to understand rectangular hyperbola slightly. Probably we will spend only 5 to 10 minutes on that. Then we will try to understand the tangents and normals. Okay. So, again there will be two different lectures, two separate lectures on rectangular hyperbola. We will deal with them separately. Okay. So, let us start. So, till now we have understood all forms of hyperbola, but there is one more form which can be derived using two perpendicular lines. So, for example, if you take the earlier standard form of our hyperbola, x square by a square minus y square by b square equal to 1. So, here there are two basically perpendicular lines which are x and y axis. Now, there is one variable point P here whose distance from x axis is, let us say, x, and whose distance from y axis is, let us say, y, okay, or the other way. I think I have done a mistake here. So, distance from y axis is x, distance from x axis is y. So, here we can relate these x and y with perpendicular distances from two mutually perpendicular lines. So, let us say I name this as d1, I name this as d2, then d1 square by a constant minus d2 square by a constant will give us always one hyperbola. So, here if you are taking distance d1 to be with positive sign, that means the other one, that means the d2 from where you are taking, that becomes the main axis, that is the transverse axis. So, that means if let us say there are two perpendicular lines like this, and there is one point P here, and whose distances from these two lines are, let us say, d1 and d2. So, here also the same logic is valid, that d1 square by a constant, let us say some k1 minus d2 square by constant k2 equal to 1. This always gives us hyperbola provided k1 and k2 are positive numbers, or both also can be negative numbers. Now, based on whichever coefficient is positive, we will choose the transverse axis and the conjugate axis. So, in general, if we just get L1 square, where L1 is a linear expression divided by constant, let us say a square, and L2 square by b square equal to 1, this also will give us always one hyperbola. For example, let us say I give one equation like this, x minus y plus 1 whole square by, let us say, 9 minus x plus y minus 2 whole square by, let us say, 16 equal to 1. What is this equation going to be? Of course, this equation is going to be a hyperbola. Okay. So, this way also we can try to derive equations of hyperbola using two perpendicular lines, which could be taken as transverse and conjugate axis. Okay. So, with this we completed all forms of hyperbola, and now we will study asymptotes in more depth. Okay. So, if you want to take a snapshot, take a snapshot. Okay. So, next, so when it comes to the asymptotes, we are basically taking the hyperbola x square by a square minus y square by b square equal to 1, and also its conjugate. So, for these two hyperbolas which are mutually conjugates of each other, the asymptotes are going to be exactly same. And here if you observe, this darkened hyperbola and this dotted hyperbola, both will be having the same asymptotes, which are basically y equal to plus minus b by a into x. Now, also I have explained the style of calculating these asymptotes. In place of 1, you just have to put 0 to get the asymptotes, and in place of 1, if you put minus 1, you will get the conjugate hyperbola. Okay. And also we have understood that because the diagram is symmetric, both asymptotes must be intersecting at the center of the hyperbola. Okay. So, that is our second point. Now, the third point, the axis of the hyperbola are the angle bisectors of the asymptotes, because these bisectors are basically symmetrically placed, and hyperbola is also a symmetric diagram. So, we can simply say that the transverse axis and the conjugate axis are basically the angular bisectors of the asymptotes. And also using the diagram or otherwise we can find the angle between the asymptotes. So, this we have understood in the last lecture also, because the slope of this equation of the asymptote is b by a. If we take this angle as theta, then it becomes tan inverse of b by a. So, because angle between asymptotes is 2 theta, so we can say that it is going to be 2 into tan inverse b by a. And we know that E square is going to be equal to 1 plus b square by a square. We already know this. So, from here if we take this theta to be tan inverse b by a, we get tan of b by a, we get I will just write it here, theta is tan inverse b by a. So, from here we will get tan theta is equal to b by a. So, that means we can say that b square by a square is nothing but tan square theta. So, 1 plus b square by a square is going to be our sec square theta. So, if we know that this is going to be equal to E square, so basically we are getting E to be equal to sec theta. So, where theta is basically tan inverse b by a, and here remember that we are taking both a and b to be positive values. So, b by a ratio is positive, so angle is positive, and that too it is in the first quadrant. So, we do not have to put mod sign here because sec theta is also a positive quantity. So, we can directly say that if we simplify this, we will get theta is equal to sec inverse of E. So, we can say that angle is also 2 into sec inverse of E, but there is also important result here that we have observed, that eccentricity is always going to be sec theta. If we know the angle between asymptotes to be 2 theta, then the eccentricity is going to be sec theta. But if the angle between asymptotes is alpha, then eccentricity E will be equal to sec of alpha by 2. Okay. So, you have understood this idea. So, these are basically the same points. Okay. Now, when it comes to the rectangular hyperbola, the asymptotes are supposed to be perpendicular. In fact, this is the point from where the definition of rectangular hyperbola will start. Okay. Next, if the angle between asymptotes is theta, then the eccentricity is basically sec theta by 2. This also we have observed in the earlier derivation. Okay. Come on, make a note of this. And also this derivation. Okay. Can we move on now? Okay. Next. So, basically asymptotes are the limiting cases of the radius vector drawn from center to the hyperbola. For example, if you take this diagram, this is our center. Okay. So, I will take this color. So, from center, let us say I am taking a point here. So, this becomes our radius vector. Now, if I vary this radius vector, that means as I vary point on the hyperbola, this radius vector is going to vary. So, as I keep varying the point here on the hyperbola, this radius vector will cover this entire region which is already shaded region. Similarly, for the other branch, if we take the variation of radius vector, it will cover this entire region. Okay. So, this is the region which is limited by the asymptotes of the hyperbola. So, that is basically the point that we have presented. What is it? Asymptotes are the limiting cases of the radius vector. Okay. And when radius vector is at infinity, we get this asymptote, and it is at this infinity, we will get the other asymptote, and likewise we can also understand. Okay. Also, there is one more geometric meaning, that asymptotes are also limiting cases of the tangents. Okay. That means beyond these we will not be able to get tangents. This also we have observed in the last lecture. I have explained it with a teaching stick also. Okay. Next, equations of the hyperbola and its pair of conjugates always differ by a constant. So, that means if I know that the asymptotes are, let us say, L1 and L2, L1 equal to 0 and L2 equal to 0 are basically asymptotes, let us say, then L1 into L2 equal to 0 becomes the equation of pair of straight lines of the asymptotes. So, here L1 L2 plus constant equal to 0, if I do this, I will definitely get the equation of hyperbola. Now, k depends on the points through which it passes or the given conditions. So, if asymptotes are given to be L1 and L2, we can always take the equation of hyperbola as L1 into L2 equal to a constant, okay, or the other way. So, that is basically this point which is about the asymptotes. Now, also we can connect the conjugate hyperbola with the same asymptotes. Okay. So, how do we do that? We will see that in the next point. Equations of hyperbola and its pair of asymptotes differ by a constant, this we have understood, and two mutually conjugate hyperbolas also differ by a constant. Okay. So, if we observe here, if let us say s equal to 0 is the equation of the hyperbola, then by just adding a constant lambda to s, we will get the equations of asymptotes. And if I add, let us say, 2 lambda, the same constant is added 2 times, then we will get the equation of the conjugate hyperbola. Now, this is one point which is derived from the earlier point only, that asymptotes and the hyperbola, these two equations differ by a constant which is lambda. Now, if I add another lambda, I will get the conjugate. But how do we identify this lambda? How do we calculate this lambda? Come on, how do we do this? Think again. Suppose if s plus lambda is equal to 0, this is the equation, and we got only the asymptotes. Now, having two lines as the asymptotes, how many hyperbolas are possible? We can get infinite hyperbolas. Now, just because asymptotes are given, it does not mean you have the equation of the hyperbola completely or you have the idea of hyperbola completely. It does not mean that. You need one more data point. What is the data point? Either it is represented by any information like length of lattice rectum is this much, or let us say focus is this much, this point, or vertex is this point, or the hyperbola is passing through a point. So, based on that idea, we will have to derive lambda. Okay. So, if equation of hyperbola is given, then getting lambda is one step, one idea, one style, but equation of asymptotes is given, then getting lambda is another idea. So, let me explain these two ideas clearly once again. Suppose let us say I have taken two cases here. Okay. So, one case is we are dealing with asymptotes to hyperbola, the other case is we are dealing with hyperbola to asymptotes. Okay. So, here let us say equation of asymptotes is s equal to 0, basically that means we have L1 L2 equal to 0. So, from here how do we get hyperbola? We can just take L1 L2 equal to constant and we can derive the constant, basically it could be lambda or minus lambda. We can derive this constant by putting the condition. But on the other hand, if hyperbola is given as s equal to 0 and I am interested in getting the equations of asymptotes. So, how do I get this? Here if you take this equation of the hyperbola, it needs to have both asymptotes in that equation. So, that means by adding lambda to this, basically I am getting pair of straight lines. So, for this equation to represent pair of straight lines, what is the value of lambda? That lambda is the value that is required and that we generally calculate. Okay. So, here if you want to calculate the constant, how do we do that? We make sure that s plus lambda represents pair of straight lines. From that idea we will derive lambda. But here if we want to derive the constant, what do? We have to substitute the given information, that is the extra data point, and from that we will get the value of k or lambda. Okay. So, this way we can solve the problems using this idea. Okay. So, here equation of hyperbola and asymptotes always differ by a constant. If we just know this idea, depending on situation we can react and we can solve it. Okay. Come on, make a note of this. And also this. Okay. So, now based on this idea, let us solve at least one or two problems. Suppose let us say there is a question here. Find the equation of hyperbola whose asymptotes are these two and which passes through this point. So, we got two lines here. One line is let us say L1, which I am taking as x plus 2y plus 3 equal to 0, and other line L2 I am taking it as 3x plus 4y plus 5 equal to 0. Now, if I multiply these two, then of course I am going to get equation of asymptotes. In which form? In pair of straight lines form. Now, to get the equation of hyperbola, what do we have to do? We have to add one extra constant. Either you take the constant in RHS or LHS, it does not matter. So, let us say equation of hyperbola be L1 L2 plus some lambda is equal to 0. Now, how do we get this lambda? By substituting the point. Okay. So, if I take x plus 2y plus 3 into 3x plus 4y plus 5 plus lambda equal to 0, and if I substitute the point 1 comma minus 1, I should be getting the lambda. Okay. So, let me just put 1 comma minus 1. So, what do I get here? If I put 1, I will get 1 plus 2 into minus 1 2 into minus 1 plus 3 into, similarly here 3 into 1 plus 4 into minus 1 plus 5 plus lambda, this must be 0. So, what is the value of lambda that we are getting? So, here we are getting 4 minus 2 which is 2, and here we are getting 8 minus 4 which is 4 plus lambda is equal to 0, which means lambda is equal to minus 8. So, we just have to put that minus 8 here. Okay. So, what do we get? I am just multiplying and writing. Okay. So, x into 3x, it will give me 3x square. Now, 2y into 4y, that will give me 8y square. Now, what about xy term? Here x into 4y, 4xy, here 2y into 3x, 6xy. So, 4xy plus 6xy is plus 10xy, and again x terms, x into constant and x into constant. So, 9 plus 5 is 14, so 14x, and similarly now y term, 2 into 5 10, 4 into 3 12, so it becomes plus 22y, and what is the constant here? 3 into 5 is going to be 15, but 15 minus 8. Okay, so, I will just write as 15 plus lambda, which is going to be minus 8. Now, if we just simplify this, we will get the constant term. So, that will give us the equation of hyperbola. Okay. So, this way if asymptotes are given, we can get the equation of the hyperbola by taking this constant lambda as an extra term. Okay. Come on, make a note of this. Okay, can we move on now to the next idea? Suppose let us say there is an equation here given. Okay. So, here this equation is the equation of hyperbola, and the question is to find the equation of the conjugate hyperbola. So, basically here s equal to 0 is given as equation of hyperbola. This is the hyperbola given. Now, to get the asymptotes, what do? We put s plus lambda equal to 0. This must give me equation of asymptotes, but this equation is going to be in POSL form, that means pair of straight lines form. So, applying the condition for POSL, I can get the value of lambda, and then after that to get the conjugate, what do we have to do? We have to do s plus 2 lambda. Okay. So, this will give me the conjugate hyperbola. Now, how do we get lambda? So, let us get lambda directly from here. Okay. So, I will take the equation to the next page. It becomes x square minus xy minus 2y square minus 4x minus y plus 5 plus lambda is equal to 0. So, I have basically taken s plus lambda equal to 0. Now, this must represent two lines. So, when will any general equation represent two lines? When all hot girls having boyfriends go for cinema. When all hot girls having boyfriends go for cinema, then the equation will represent two straight lines which are pair of straight lines. So, how do we do that? Just get the values. So, here A is equal to 1, H is equal to minus 1 by 2, B is equal to minus 2, and this is going to be 2G term. So, here G becomes equal to minus 2, this is going to be 2F term. So, F is going to be minus 1 by 2, and the constant C is lambda plus 5. Now, we want to apply this condition that all hot girls having boyfriends go for cinema. This must be equal to 0. So, which implies we will get some value of lambda. So, let me just put all of them. All hot girls having boyfriends go for cinema. Okay. So, here we just have to find out this value and equate that to 0. Okay. So, let us just do that. So, if I take lambda plus 5, okay, basically I am going to take this column. Okay. So, then it will become minus 2 minus 1 by 2. Next, if I take this term minus 1 by 2, so that means 1 by 2 into what will be its minor? 1 into minus 1 by 2 minus 1 by 2, and here minus of this term, so it becomes minus 1. Similarly, when I take this term which is minus 2, so again we need this minor which is going to be 1 by 4, and here again minus into minus it becomes plus, again there is one more minus, so it becomes minus 4. This must be equal to 0, we just have to simplify this. Okay. So, it becomes lambda plus 5 into, this is going to be 5 by 2. So, basically this is minus 5 by 2. and here these are anyways constant, so we just have to simplify them. So 1 minus 16 by 4, it becomes minus 15 by 4. So minus into minus, it becomes plus, it becomes 15 by 2. So plus 15 by 2, and similarly here also, here it is minus 3 by 2. So minus 3 by 4 it becomes, this must be equal to 0. So we can directly write lambda plus 5 is equal to, so here it becomes 30 by 4 minus plus 3 by 4 divided by minus 5 by 2. So what will it give us? It is minus 27, minus minus will get cancelled, and there is 5. So it becomes 27 by 10. So lambda must be equal to 27 by 10 minus 5. It becomes minus 23 by 10. Okay. So by adding this value, we can get the value of lambda. So there must have been some kind of mistake here. So I'll just verify if I have done any mistake here. Okay, so this seems fine. So let's say we evaluated the constant and we got the lambda. So that means by taking by just adding this 2 lambda, I am supposed to get the equation of the conjugate hyperbola. Okay. So this is how we find out lambda and we substitute and solve it. Okay. So here basically we have understood the main idea of how to solve this problem. Okay. But there is a much better method. Okay. So first copy this, I will give you the other method immediately after this. Okay. Come on. Okay. So can we move on to the next method? So next method is this. Suppose here, instead of finding this delta, we can also apply other method. What is the other method? We can try to factorize this given equation into two straight lines. It's always easy. Why is it easy? Because always in hyperbola, the equation always comes as product of two lines plus some constant. So we understand that equation of asymptotes is always in the form N1 N2 equal to 0. Equation of asymptotes is always in the form L1 into L2 equal to 0, and hyperbola will be L1 into L2 plus some constant equal to 0. So what we try to do is, we try to factorize this into pair of two lines. That means into two linear factors. So in hyperbola, it's always easy to factorize. Okay. So here I am going to give you the method of factorizing. So because in hyperbola getting factors is easy, I am using that method. But if it was some other curve, definitely I will not be using this method. Only for hyperbola I am using this method. Okay. So what is the method? We want to factorize this. We know that every hyperbola is of the form L1 into L2 plus lambda equal to 0. So we know for sure that we are going to get two linear factors. So what we do is, we just factorize only these three terms. Okay. Only these three terms we try to factorize first. So it's always possible that we will get two factors there, it's always possible. So here if I just factorize only those two terms, what are the factors I get? We can write this as, we can also split the middle term and factorize or do whatever you want. So here we are going to get x here and also x here. So y here and 2y here, and one should have minus sign, so minus into plus. So this way we can easily factorize it. So here we are getting all the terms. So that means if we are able to factorize only these three terms, just by adding another constant, we are going to get the other terms also. So what I will try to do is, I will take the equations like this: x plus y plus a constant a into x minus 2y plus some constant b, and if I am able to compare this with that, it should match. So I will compare only x and y terms. Okay. So suppose, let us say, if I expand this, what am I going to get? This is just an experiment based on our observations. Okay. Based on this observation, this is an experiment that we are hitting. Okay. So what do we get? X square minus xy minus 2y square. These terms anyways we will get. Now let me explore the other terms. So if I take x terms, what do I get? X into a plus b. And if I take y terms, what do I get? Y into b, and here minus 2y into a. So I will get minus 2a plus b, and the constant term is going to be ab. This is fine. But we are going to just compare these two terms and solve for a and b. If I am able to get the values of a and b, that means I have cracked the factorization. So what I will try to do is, I equate this a plus b with minus 4, and I will equate this minus 2a plus b to minus 1, and I will try to solve for a and b. So suppose here, if I subtract 1 from 2, what do I get? Minus 3a is equal to plus 3, right? So which means a must be equal to minus 1. If I put a equal to minus 1, I will get b equal to, it becomes minus 3. So also we can verify it here. So a equal to minus 1 will make this 2, and b equal to minus 3, 2 minus 3 is minus 1. So this is perfect match. So what are the lines? Our lines are going to be this, I will just write them in red color. Our lines are going to be x plus y minus 1 into x minus 2y minus 3. These are our lines. Now that means I can get the value of AB after I got the values of A and B. So AB here must be 3 units, which means this constant term should match this 5 plus lambda term. So that means 5 plus lambda must be equal to how much? It must be equal to 3. So lambda must be minus 2. So if lambda is minus 2, and here if you understood, here what have we done? S plus lambda equal to 0 must give the asymptotes. So for this to give asymptotes, constant term must be 3. So that means we found the lambda minus 2. So just by adding minus 2 to the given equation, I can get the equation of asymptotes. And if I add minus 2 2 times, I will get the equation of the conjugate hyperbola. So what is the required equation? Required equation is going to be x square minus xy minus 2y square minus 4x minus y plus 5. This is the given constant, and I have to add 2 into lambda. Now lambda is minus 2, so I can just add minus 4 here. So what is the answer? Answer is going to be x square minus xy minus 2y square minus 4x minus y plus 1 equal to 0. This becomes our equation of the conjugate. Okay. So I hope you have understood this technique. So the beauty of this technique is the factorization, and in hyperbola, factorization of the equation into two straight lines is always possible. So I have hit this idea. Okay. Now even if we are not able to get the factors smoothly like this, we can also use the idea of quadratic and get the roots, which will give you the slopes. Okay. So for example, here in this equation, if you have taken the ratio of y by x, so it becomes minus 2 into y by x whole square minus y by x plus 1. So let us say I put y by x to be m and solve this. So it becomes minus 2m square minus m plus 1 equal to 0. From here anyways I am going to get values of m, which are basically the slopes of these two lines. Okay. So even if we are not able to get smooth factors, we can also use the formula of quadratic and get the factors. Okay. So, when it comes to hyperbola, factorization is easy. So, the conclusion is we use the factorization better than the delta. Okay. Come on, copy this. This also. Okay. So, can we move on? So, with this we have understood the concepts of asymptotes. We have also understood the ideas of deriving hyperbola from asymptotes, deriving asymptotes from hyperbola. So, suppose in case if in this question also, if this is given as hyperbola and question is to calculate the asymptotes, what do? We can also follow the same approach. Okay. Can we move on now to the next idea? So, we will touch the concept of rectangular hyperbola a bit and then we will move on to the concept of tangents. Okay. So, in rectangular hyperbola, what we have understood is this: if the angle between the asymptotes is 90 degrees, it is called as rectangular hyperbola. Now that we have understood the basic idea of the angle between asymptotes, which was basically equal to 2 into tan inverse b by a. So, by equating this to pi by 2, we can get b to be equal to a. So, hence we can also conclude that length of transverse and conjugate axis are also equal. We have also derived this in the last lecture. Now, because b is equal to a, eccentricity can be directly calculated, because formula for eccentricity is 1 plus root of 1 plus b square by a square. B is equal to a, so this becomes 1, it becomes root of 1 plus 1, which is the root 2. These are simple ideas of rectangular hyperbola. Now, for the rectangular hyperbola, for the equation, let us say we want to derive one standard equation. Of course, this is not the standard equation, but this is one conventional equation. So, if you take this hyperbola x square by a square minus y square by b square equal to 1, and if I put a equal to b here, of course, I will get this equation. So, in general we can say that x square minus y square equal to constant will always give us one rectangular hyperbola. So, this is normal hyperbola only. So, when we look at this equation, it looks like normal hyperbola only. Of course, there is one special form that we will study little later, but this also becomes one conventional form. Now, for this rectangular hyperbola, can we derive vertex, focus and all characteristics? Of course, we can. So, what do we have to do here? We just have to put, wherever we see B, we have to put A, and wherever we see E, we have to put root 2. So, how do we derive all of them? Can we derive them right now? Of course, if you want to derive them on your own, of course, you can take a pause and you can solve it, but it is always better that you derive them on your own. Okay. So, but here I will directly write the coordinates. Now, center of this is going to be 0, 0. Vertices are going to be plus minus a comma 0. Foci are going to be plus minus a root 2 comma 0, because we know that AE are the foci. Okay. And directrices a by root 2. So, that means x equal to plus minus a by root 2, that will be the directrices. Length of transverse axis will be 2a, length of conjugate axis also will be 2b, but that is same as 2a. Eccentricity is root 2, this we have already learned. Length of lattice rectum here also becomes 2a, because it is going to be 2b square by a. Now, b and a are equal, so I can just put a in place of b, so it becomes 2a. So, if you remember here, the lattice rectum, the conjugate axis, the transverse axis, all three are equal for rectangular hyperbola. Okay. So, transverse axis, conjugate axis and also lattice rectum, all three are equal. So, if any question comes like this, in a certain curve, in a conic, main axis and the minor axis, or let us say transverse axis and conjugate axis and also latus rectum are equal, then what kind of hyperbola it is? Of course, rectangular hyperbola. Ends of latera recta, of course, you can calculate them as plus minus a root 2 plus minus ae plus minus b square by a, which is same as a. Okay. And further, equation of the auxiliary circle is still same because we are still using the a for semi transverse axis. Okay. So, these are basic points of rectangular hyperbola, which is x square minus y square equal to a square. Okay. Now, similarly, let us try to understand the other form. Okay. So, I will just explain this other form once and then I will move on to the concept of tangents. So, here if I take this hyperbola, which is of course rectangular hyperbola, and if I try to understand this rectangular hyperbola diametrically or geometrically, sorry, geometrically, how will the diagram look like? So, here this is one y axis, this is x axis, and if you look at this equation, x square minus y square equal to a square, if you look at this equation, now recall how do we get the equations of asymptotes? By putting the constant term to be 0. So, that means here equations of asymptotes will become x square minus y square equal to 0. So, that means y equal to plus minus x are the equations of asymptotes. So, that means this y equal to x line and this y equal to minus x line, these lines are the asymptotes. Okay. Now, how would the graph look like? So, here there is one point a comma 0, it has to pass through a comma 0, and here another point which is minus a comma 0, it has to pass through minus a comma 0. Now, the hyperbola will look like this. Okay. Similarly, here also it will look like this. Okay. Now, if you remember, this y equal to x line is already making 45 degrees with x axis. So, this angle is going to be 45 degrees. Okay. Now, you can of course understand the remaining ideas of the entire setup of foci, directrices, ends of latera recta, everything here. But understand that if I rotate this diagram by 45 degrees, I am rotating the curve, not the axis. Okay. So, if I rotate the curve by how many 45 degrees, then I will get a curve like this. Okay. So, I will use green here, I will be getting a curve like this. Okay. This green curve. So, in a way we can say that if I rotate that by 45 degrees, I am going to get a curve like this. Okay. Now, this curve is very famous curve. You might have already studied this in functions. This is the reciprocal function, which is also called as the rational function, which is y equal to 1 by x form. Okay. Now, y equal to 1 by x is one of the rectangular hyperbolas, but general equation is not of course this. We put one constant here. Okay. Why are we putting positive constant? Because we want product of both x and y coordinates to be positive. So, if the curve is in first quadrant and third quadrant, x into y must be always positive. If the curve is in this quadrant and this quadrant, which are second and fourth quadrants, then x into y must be equal to minus y, minus into some constant square. Okay. So, this is basically the idea of the rotation of rectangular hyperbola. Okay. So, when we rotate this blue hyperbola, we will get the green hyperbola, whose equation we can always take it as x into y equal to c square. So, here if you understand, the rotation is for the curve, not for the axis. Now, if you want to keep the curve constant and rotate the axis, you have to rotate the axis in clockwise direction and by 45 degrees. Okay. So, this is the basic idea that we have discussed here, which is When rotated, this curve when rotated by pi by 4 in anti-clockwise direction gives the curve which is x into y equal to c square. Now, is this c exactly equal to a? Of course not. That we will derive based on the situation. Okay. So, but we can understand that x y equal to c square becomes one standard equation of rectangular hyperbola. So, the main idea of discussing this is to explain you the equation of x y equal to c square. Of course, we will study this separately when it comes to the problem solving or when it comes to the other ideas. Okay. So, this is the basic idea of rectangular hyperbola. Okay. So, in general, if I take x y equal to c square, I am going to get the graph like this, and if I take x y equal to minus c square, I am going to get graph in only second and fourth quadrants. Okay. So, come on, make a note of this. Okay. Next. So, this is the graph of the rectangular hyperbola, and we can take the point on the rectangular hyperbola as ct comma c by t, that is fine. So, when we are taking this x y equal to c square, we can always parameterize this as x equal to ct and y equal to c by t. We can always parameterize it like this. Okay. So, this is the basic idea that we have discussed earlier. Now, this is your job. Okay. So, I will give this as homework for you. Of course, I will discuss this when I am touching the rectangular hyperbola separately, but it is your job. I am giving this as homework for you. Okay. So, now whether I will discuss this in the next lecture or next to next lecture, that is immaterial for you. You have to derive all of them and come prepared for the next lecture. So, for the curve x y equal to c square, for the curve x y equal to c square, what is the center? Of course, center is origin only. What are the vertices? What are the foci? What are the equations of directrices, ends of latera recta? All of them you have to calculate by next lecture and come. Okay. So, I hope you will enjoy this problem. Okay. So, come on, take a snapshot of this. Okay. So, now can we proceed? Okay. So, now let us move on to the concepts of tangents and normals. So, if let us say there is a point x1 y1 on the curve which is hyperbola, we can always get the equation of tangent as s1 equal to 0. Now, this derivation you can do it either by the idea of finding the derivative of the curve and getting the slope and then applying slope point form of the line and get the tangent. Okay. So, that is fine. Also, you can understand that because this is the last curve of all conics, this point is same starting from circles. Circle, parabola, ellipse, hyperbola, for all of them equation of tangent is always same. Okay. And again, instead of taking the point as x1 y1, if I take the point in parametric form, that is a sec theta and b tan theta, so then equation of tangent will become x by a into sec theta minus y by b into tan theta equal to 1. So, I have just substituted a sec theta b tan theta for x1 and y1 here. Okay. Now, suppose let us say I am interested in normals. What is the idea that I have discussed earlier? There is a pattern for tangent and normal. Okay. So, let me just explain the pattern here. So, if I am taking the point as x1 comma y1, then equation of tangent becomes xx1 by a square minus yy1 by b square equal to 1. This becomes the equation of tangent. Now, if I am interested in normal, okay, so this is my tangent and I am interested in getting the equation of normal. What is the idea? Take the coefficients of x and y and flip them. So, for example, here what do I get? A square by x1 into x, basically I flipped it, and here also I have to flip it. So, it becomes b square by y1 into y. Now, what is the next step? Reverse the sign. If there is minus sign, put plus here. If there was plus, put minus. And then forget about RHS. Don't remember RHS. RHS can be derived directly by substituting x equal to x1, y equal to y1. That is the point on the hyperbola. So, this will give us a square plus b square when we substitute x1 comma y1. See how simple it is. And similarly, if we take the other form, what is the other form? X by a into sec theta, y by b into tan theta. Equal to 1, this is going to be my tangent, and I am interested in getting the normal here. So, how do we do that? To get the normal, just flip the coefficients, okay. So, what do we do here? Just flip the coefficients. So, what do I get? A by sec theta into x, and here also b by tan theta into y, and sign you have to reverse, equal to, put x equal to a sec theta, put y equal to b tan theta. So, what do we get? A square plus b square here, okay. So, this way we can get the equation of normal, okay. So, here what you have to understand is that we have to remember only this form, only this S1 equal to 0 we have to remember, remaining can be calculated only by using the pattern. If you remember the pattern, you won't even forget the equations, okay. So, if you remember pattern, you won't even forget the equations. So, try to remember the pattern, okay. So, this way we can understand the direct pattern and also we can derive equations, okay. So, I hope you have liked this. Come on, make a note. Okay. So, that is basically our next point, which is the equation of normal. So, if you have noticed, it is exactly the same, okay. So, I think we will stop at this point. There is also this point which you can derive by next lecture. I have left them intentionally blank so that you will derive them. So, what is your other homework? Other is what happens if this line y equal to mx plus c is a tangent. If it is a tangent, then it has to be in this form. So, try to compare them and try to get a relation between c, a and m, okay. So, we will meet again in the next lecture with more concepts. Until then, have a great learning day. Learning shall never stop.